Hey everyone, so today I've managed to get my hand on today's paper 3 for the AQA GCSE calculator paper. I thought we'd have a look through, see how we got on, see what was involved this year. A village has 4 bus stops. A bar chart shows information about the people at the bus stops at 3 p.m. on one day. 2 people were at the football ground bus stop. Show this information on the bar chart. So really I want to use my ruler and a pencil. If I'm in the exam, I'm just using a pen so it shows up to show that 2 people were at the football ground. How many more people were at the school bus stop than at the post office bus stop? So the school is 13 and the post office is 4. So 13 take away 4 is 9. Here are the 4 temperatures in degrees Celsius. Write down the temperatures in order, starting with the coldest. So the coldest would be -7, then -5, and -1, then 3. Here are the first 3 terms of a linear sequence. Write down the next term. So I can see we're going up in 6s. So I think the next term, don't be afraid to get your calculator out for each question on the calculator paper. 17 plus 6, 23. Describe the term-to-term rule. Well, the term-to-term rule is add 6. So term-to-term rule asks us what we're doing from term to term. That's not the nth term, that's something different. Get that all to fit on. Luca spends 71p. He pays the exact amount with 4 coins. List the coins he uses. So I'm just going to think about what I might use and see if I can get there. So he's going to spend 71p in 4 coins. So let's say that's a 50p, a 20p. Well, that's already 70, so I'm bust. So let's have a 50p, a 10p, another 10p would get me 70p, and then 1p. So 50, 60, 70, 1. So a 50p, a 10p, a 10p, and a 1p. Complete each statement using one of these symbols. So I always remember that the big end of the sign points towards the big thing. The small end of the sign points towards the small thing. Because crocodiles will try and eat big things. So this is the bigger number. Then in these are the same as each other. With this one, 5 over 2, you can always check it on your calculator. What is 5 over 2? 2.5. So this one's larger, so large end at this side, small end at this side. Here are 3 solids. How many faces does the cube have? Well, the faces are the flat sides, so that would be 6 sides on a cube. How many edges does the square base pyramid have? So the edges are like the bones, so 1, 2, 3, 4 for the base, and then 1, 2, 3, 4, sort of joining it up with that central point. So that's 8 edges altogether. How many vertices does the cone have? Well, our vertices are our corners, so just one vertice on a cone. Here is a number machine. Complete the number machine. Oh, nice, easy question here. So I start with 12. I take away 4. That gives me 8. I times it by 5. I get 40. Nice, easy question. Here is a different number machine. I start with 7. Something happens. I divide by 2 and I get 9. Complete the number machine. So I'm going to go backwards here and times by 2. So 9 times by 2 gets me 18. So I need to do something to turn 7 into 18. Easiest thing to do would be to add, so I'm going to say it is add 11. Check it on your calculator to be sure. So 7 add 11 equals 18. Divided by 2 equals 9. The function machine works. Here is a different number machine. So I've got an input of x, something happens, well, it gets multiplied by something, subtract something, and I get y. When x is 5, y is 13. When x is 10, y is 28. Complete the number machine. So I'm just going to have a go with it here, really. I'm going to use the space down here to try it one way, try it another, see if it works. So I'm targeting 13 and I want to do a takeaway. So let's say 5 times 3 is 15. 15 take away 2 is 13. Will that work with 10? 10 times 3 is 30. Looks good. 30 take away 2 equals 28. So I'm quite sure that this is times 3 and take away 2. A pack of oranges costs 40p. A bar of soap costs £2.20. A basket costs £7. Dan buys 2 packs of pegs. So 2 packs of pegs. In fact, I'm just going to go straight for it. So 2 times 40p. 1 bar of soap and 1 basket. What fraction of the total cost is the cost of the basket? So 2 pegs at 40p, 2 packs of pegs at 40p is 80p. He buys 1 bar of soap, which is £2.20, and 1 basket. So let's get our total amount there. So we can do it on the calculator. So just careful, my 80p, I'm going to put that in as 0.8 for 80p, £2.20, and my £7. That's £10 in total. Just check, does that look right? Well, that's £3 put together with that. That looks great. So it's £10 in total. What fraction of the total cost is the basket? Well, the basket is £7 out of £10. So that's 7/10. Calculate. So straight my calculator here. The square root of 625 is 25. Plus 7 cubed, so that's 7 times 7 times 7, or I can just use my calculator button. 7 cubed, 343. Then I need to add these together. So 25 plus 343 equals 368. $8,400 fans go to a rugby match. 6,850 of the fans support the home team, right? So that information's already in my table. The remaining fans support the away team. So I'm going to stop reading the question for a second there and just fill that in. So these two need to add up to that. So 8,400 take away 6,850 gets me 1,550. 20% of the home fans wear a scarf. So 20% of these wear a scarf. Well, to find 10%, I'd divide by 10, which would give me that. And because I want 20%, I'll times that by 2. So that's 1,370 wear a scarf. So the ones that don't must be that, take away that. So 6,850 take away 1,370 equals 5,480. If I was doing this exam for real, I'd make sure I was writing down all these calculations so that my marker could see what I was doing. 2,319 of all of the fans wear a scarf. So if that's all the fans that wear a scarf, and they're the home fans that wear a scarf, let's take those off, leaving me with my away fans that wear a scarf. A lovely summary question. And then again, these two are supposed to add up to that. So 1,550 take away 949, 601. All right, 11. Work out the coordinates of B. Right, well, if that's minus 2, 5, we know that that's minus 2, and we know that that's 5. So minus 1, 1, 2, 3, 4. we've got a fairly basic scale going on here. So the coordinates of B would be -2 along, 1 down, so -2, -1. Point C is reflected in the line x equals 6, which they're drawn in here for us, to point D. Work out the coordinates of point D. So reflected in the line, if that's 2 squares away now, it'll be 2 squares away after the reflection. So that point is along the corridor, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 along, and it's 1 down. So that is 8 minus 1. Liz records the distance of some runs and the time each run takes. So I've got the distance and the time. The scatter graph shows some of the information from the table. Complete the graph by adding the missing label and plotting the 2 missing points. So I can see that this axis is time, so this axis should be distance, which is in kilometres. So it's had the missing label, I've done that, plotting the 2 missing points. So let's just check these points are here. So 3 and 14, 4 and 17, 5.5, so this one's missing, 5.5 and 20, 5.5 and 22 is there, 6 and 23, 6 and 23, it's probably the last one, but we might as well check now, 6.5 and 26, 6.5 and 26, 7 and 31, so 8 and 38, 35, 36, 37, 38, sorry, I've been reading them off, you've not been able to see them. What a dingbat. So I've just plotted that one, 8 and 38, and then I've got 8.5 and 42, so 8.5 is going to be halfway, and 42, 41, 42 on that mark there. Describe the type of correlations shown in the scatter graph. So I would say it is a positive correlation. Would I say it is strong or weak? Now all our points are quite tight, so I'm going to say it is a strong correlation. If all those points were further away from each other, I'd be saying it's weak, but I think that is a strong correlation. Right, AB is a straight line. Is y half of x? Tick a box. Right, so first let's just figure these things out. So that's a straight line, so 180 take away 127 tells me that that's 53 degrees. This is 360. So 360 take away the 163 I'm being told about. Take away our 90 degrees for the right angle, leaves that as 107 degrees. Is y half of x? So let's do 107 divided by 2. 53.5. So no, it's not exactly half, is it? It's not half of x. It's nearly half, but in maths we care about absolutes. Alright, multiply out. Nice expanding bracket question. So, going to multiply what's in front of the brackets by everything inside. 3 times 2x is 6x. 3 times 8 is 24. So it's 6x plus 24. Complete the statements. Something add 5x is 9x. Well, 4x add 5x is 9x. Y times y would be y squared. Got some nice questions in here. Something take away 2t would just leave me with 1t. So 3t take away 2t would leave me with 1t. Tins of beans are sold in shop A and B. In shop A, 1 tin is 64p, or you can buy 4 tins for the price of 3 tins. In shop B, 1 tin is 62p, or you can buy a pack of 3 tins for £1.70. But there is a 10% reduction in price on all packs. At which shop is it cheaper to buy 20 tins? Right. I can buy 4 tins here for the price of 3. So that would be 4, 8, 12, 16, 20. So that's 5 packs. You can buy 4 tins for the price of 3 tins. So the price of 3 tins is going to be our 64p, so 0.64, so I'm dealing in pounds and pence, times 3. So 0.64 times 3 equals £1.92. So 5 packs at £1.92. So 5 times 192 would be £9.60 for shop A. So for shop B, there's 10% reduction on all packs. That's just the packs, isn't it? Not the... So 10%, let's do the 10% reduction on the packs first. So 10% is going to be 17p. So 10% off is going to be our £1.70. Take away our 17p for £1.53. So how many packs of 3 will I need? So 20 divided by 3, 6 packs of 3. 6 times 3 is 18, so then I need 2 single tins. So my 6 packs of 3, is that on chart? No, it's not. 6 times £1.70. 6 times £1.70. So that's £10.20. And then 2 single tins at 62p, so that's 2 times 62. £1.24. Add them together, £10.20, add £1.24 equals £11.44. So quite clearly shop A is being cheaper, but it's asking us by how much by. So state how much. So shop A is cheaper by our £11.44, take away our £9.60. £11.44, take away £9.60 by £1.84. There are 30 students in a class. 12 of the students have school lunch. Work out the ratio of students having school lunch to students not having school lunch. Give your answer in its simplest form. So, students having school lunch to not. 12 have. So it's fair to assume that 18 don't, because those two numbers add up to 30. So 12 to 18 is the same as 6 to 9, which is the same as 2 to 3. In a different class, students wearing glasses to students not wearing glasses is 3 to 8. What fraction of students in this class wear glasses? So wear glasses is 3 groups out of a total of 11 groups. The ratio 4 to 9 is written in the form 1 to n. Work out the value of n. So if I've got 4 to 9 and I want this first number to be 1, I'm dividing this side by 4. So I'll do the same over here. So 9 over 4, don't be afraid to use your calculator in the exam, 2.25. So n would be 2.25. Here are the first 3 patterns in a sequence made up of small squares. Pattern 1, 2, 3. On the grid, draw pattern 4. So what's happening? Just one at the edge, one in the centre, then 2 by 2, 3 by 3, but just one on the edge each time. So let's go for my one on the edge, and then I'm going to go 4 wide, 1, 2, 3, 4, one on the edge, bring this down. I would of course show much greater care in the exam, but this is just a quick look it. There we go. The expression for the number of small squares in a pattern the expression for the number of small squares in pattern n is n squared plus 4. Work out the least value of n for which the number of small squares is greater than 500. Work out the least value of n for which the number of small squares is greater than 500. So really I want that to be greater than 500. So n squared plus 4 is greater than 500. So take away 4 will give me n squared is greater than 496. And then square root both sides to undo that squared. Give me n is bigger than square root 496, 22.27105. So at this stage, you might be a little bit unsure. Is my answer 22? Is my answer 21? Is it 23? So let's just use these numbers, put it in these terms so we feel good about it. So I'm going to try with 22, I'm going to try with 23, and that way I feel 100% accurate about whether I'm getting this mark or not. So just substituting into here, 22 times 22 for n squared equals plus 4. That wasn't greater than 500. Hopefully should be seeing it with this one. 23 times 23 equals plus 4, 533. Which is what it says here, isn't it? N is greater than 22.2, so it must be 23, but it can really help in the exam to just feel that extra bit of confidence come through. All right, question 19. We've got a Pythagoras question. Use Pythagoras' theorem to work out the value of x. So I always get my students to draw it like this, because this square add this square is this square. So 24 times 24 is 576. 31 times 31 is 961. So the area of this square must be these two added together. So 576 add 961, 1537. So if the area of that square is that, I just need to square root it to find the side length. So square root of my answer gives me 39.20459157. Give your answer as a decimal. I will round that off even though they've not asked, but I'll leave that there so they can see it. So 39.2. You best put it on the answer line too. Right, 20. Rick claims most of his flats in his 8-floor building are energy efficient. He samples 45 flats from floors 1 to 5. Give a reason why the sample may not be useful in testing Rick's claim. Well, it's not a broad sample. It may not pick up differences with some of the higher flats. I think that's a pretty extensive answer. I think just saying it's not a broad sample would be enough to get your mark there. Right, 21. 3 bracket x minus 1 is identical to 3x minus 3 is an identity. Tick one box. It's true for all values of x, it's true for some values of x, it's true for no values of x. All and always. Right, K hires a digger. The cost per day is £24.50 for the first 5 days. Feel my calculator coming on. Reduced by 20% for day 6. The same as day 6 for day 7 onwards. The total cost is £259.70 for how many days did Kay hire the digger? So it's that for the first 5 days. So let's just do £24.50 times 5 to figure out how much that is for the first 5 days. £122.50. It's reduced by 20% for day 6. So 10% would be 2.45. So 20% must be £4.90. So my £24.50 minus my £4.90 is a new rate of £19.60 a day. Oh, so because it's just that a day now, it's just how many of those are in what's left over. So it was that for the first 5 days. Let's take that off of our price there. So £259.70, take away £122.50. Gives me £137.20 left over. I want to know how many of those go into it, so I'm going to do £137.20 divided by my £19.60. Hope that'll come out with the whole number. It does, which is a good sign. So that is an extra 7 days. Need to be careful. For how many days did Kay hire the digger? Well, it's 5 days there and 7 days there. So 5 plus... Oh, no. Yeah, it is, yeah. 5 plus 7 equals 12. 12 days. The front elevation, so this is looking at something like front on, of a cuboid is shown on this centimetre grid. The volume of the cuboid is 42 centimetres cubed. Draw the side elevation on this centimetre grid. So this is the front elevation. I can take those measurements of it. So that's 3 and that's 2. So 3 times 2 equals 6. Something times 42 equals 6. So 42 divided by 6 is 7. So if I was looking at it from the side, it's going to be 2 by 7. 1, 2, 3, 4. I should be using my ruler. Use the ruler, rule the world. 2, 4, 6, 7. On Monday, Lewis swims 50 metres in 40 seconds at a constant speed. On Tuesday, Lars swims 1.5 kilometres. Assume he swims at the same constant speed as on Monday. How many minutes does he swim for on Tuesday? Right, big question here. So on Monday, Lars swims 50 metres in 40 seconds at a constant speed. Let's get that speed out. So speed is equal to distance over time, or if you like it in the triangle. So we've got 50 metres, but it's divided by 40 seconds. So 50 metres divided by my 40 seconds equals 1.25. And then if you're unsure of your unit, think about what you've done. It's metres per second. Meters per second. On Tuesday, Lars swims 1.5 kilometres. Assume he swims at the same constant speed. How many minutes does it take him? So going back to our triangle, we're looking for the time now. I've got my distance. I've got my speed. So my distance, I'm going to put that in metres so it matches my speed. It'd be 1,500 metres. This is my speed. 1.25 metres per second. So 1,500 divided by 1.25 equals but be careful, so mine's in seconds, it's asking for how many minutes. So I'm going to divide that by 60 because there's 60 seconds in a minute. $20 minutes. Nice round amount of time. Right, in fact, on Tuesday, Lars swims at a slower constant speed than on Monday. So he's swimming slower. What does this mean about the number of minutes he swims for on Tuesday? It'll be greater, won't it? Because if he's swimming slower, he's got to swim for longer because that's how things work. Right, 4 people are taking part in a television talent show. Here are Amy's marks from the 6 judges. The pie chart represents the phone vote. So, all right, here we go. So this is judges. Make this nice and clear for myself. And this is phone. Amy's total score is found by 4 times the mean of her marks plus her percentage from the phone vote. Work out Amy's total score. That's what it says over here, but I'll do it over here so we can see everything together. So her score is 4 times the mean of her marks. So the mean I'll get by adding up everything we've got. So 8 plus 9 plus 9 plus 6 plus 9 plus 10. Total of 51. Write it down so the marker can see what I'm doing. Divided by 1, 2, 3, 4, 5, 6. Oh, that's not come out right. Oh, 51 divided by 6 equals 8.5. So we've got 4 times her mean mark, so that's going to be 4 times 8.5. Add on her percentage of the vote. So Amy got 162 degrees of this pie chart out of 360 degrees. So that's 126 out of 360, 0.45, which we should know is 45%. So 4 times 8.5, 34, add on 45. Type it in right, James, slow down. 34 plus 45. 79. I'm going to go a bit of like Britain's Got Talent maths for you. Final page. House prices on a street increase by 5.1% each year. Show that after 14 years, the house prices on the street will be at least double. So, I'm going to do this by a demonstration. So I'm going to assume price is 150,000. If we increase by 5.1%, if you're used to using percentage multipliers, this is times in by 1.051. 0.051 is 5.1% as a decimal, and that 1 keeps our original amount, so the 1 keeps the original, then that adds on that percentage. So I'm going to say 150,000, our assumed price, times my percentage multiplier, 1.051 to the power of 14, because that's how many times I times it by it for 1 year, 2 years, 3 years, 4 years, so it's going to happen 14 times. And then plug that into my calculator. So I've got a bit of an older calculator, so I'm going to do it in stages. I'm going to do my percentage multiplier first, so 1.051 to the power of 14, which is already showing is a multiplier of times 2, but completing here in this style will really show a demonstration. Would make a house price of which is double. And then I'm also just going to state what I saw when I was doing this, that this to the power of 14 equals 1.051 to the power of 14. Right, Town A has a population of 84,000 in an area of 7 square miles. Town B has a population density of 4,695 people per square kilometre. Population density is population divided by area. Which town has the greater population density? So population, it gives you everything here. This is nice. Population divided by the area in square miles will give me the population density of A. So 8,400 divided by 7, 1,200. Town B has a population density of 4,695 people per square kilometre. Which town has a greater population density? Oh, it's because this is area and kilometres. I've made it far too easy. So that is people per square mile. Whereas this is people per square kilometre. So actually let's change that into kilometres. So to go from square miles to kilometres, we times by 2.6. So I'll do my 7 times 2.6. 18.2. So actually their area is 18.2 kilometres. So Town A, 84,000 people divided by 18.2 kilometres. Excuse me, how exciting. Oh, what a treat for you if you stayed on to the end, eh? Right, so Town A, 4,615. Town B, 4,695. So which town had the greater population density? Town B. Nice one. Right. I hope everyone's done all right. I hope you've had a good maths season on the exams. I hope my videos have managed to help people out. Cheers, guys. Thanks.